Section 1.5, the equilibrium rule. If you hang something really heavy from the ceiling, like from a spring or from a string or something like that, you can see that the spring will stretch as the heavy thing is hanging from it. At some point, the spring will stop stretching, the bag hangs in the air, right? And there's some amount of tension in the spring or in the string or the rope or whatever it is that you used to tie up the heavy bag. In that case, there are two forces that are acting on that particular bag, even though it's not moving. The first force is gravity, which is pulling that bag downward, and then there's tension in the spring that's holding the bag upward. The tension in the string or the spring or whatever it is, the tension is providing a support force. It's supporting that heavy bag. Because these forces are equal in magnitude, but they're opposite in direction, that bag is stationary. It doesn't move. When the forces on an object are equal but opposite, we say that the object is in mechanical equilibrium, or in most cases we just refer to it as equilibrium. There are two situations in which an object can be in mechanical equilibrium. And in this case, we say it's in equilibrium when the sum of the forces or the net force on that object is equal to 0. This can occur when the object is at rest. There's no motion, the object's not moving. We call this static equilibrium. This can also occur when the object is moving at a constant speed. There's no change in the object's motion. It's not speeding up or slowing down, and it's not changing direction. We call this dynamic equilibrium. So once you have an object that's in motion and it's in dynamic equilibrium, so there's no net force on the object, there's no change in its motion, that object will just continue to move at the same speed in the same direction. Nothing will change until there's a net force on that object. What that also means is that objects that are in equilibrium, in mechanical equilibrium, cannot just have one force acting on them. In order for them to be in mechanical equilibrium, they have to have at least two forces acting on them. So everything on Earth that's not moving has at least two forces acting on it. The force of gravity pulling you down, and the force of whatever it is, your legs or the floor or whatever it is that's holding you up.